Hello, folks. Good morning or good afternoon, depending on where you are, or even good evening. Welcome to this week's webinar, which is our last weather webinar of 2025. And today we're going to be talking about learning from about the future by thinking about the past, specifically learning from the weather events of 2013 to 2016. So at these webinars, we talk about the weather factors that are likely important for yourself, for your business, for your portfolio, and can possibly guide you as you make your decisions about the future going forward. So thank you for being here. Welcome. My name is Dr. Hansi Singh. I am CEO and co-founder of Planette AI. I'm an Earth Systems scientist. I was a former fellow at the U.S. Department of Energy. I was also a former professor. I am currently still highly involved in Earth system modeling through the CESM working group as a co-chair there. Yeah, I love all things related to the weather, and I'm excited to talk to you today about the weather of the past and some lessons that we can learn from that. So, learning from the past to predict the future, first of all, we'll talk semantics, why understand the past. And I will say, if we carefully use the past to assess the future, it is actually very helpful. But we're going to do it carefully, specifically because, as we know, the climate is changing. And so, in many ways, the past does not resemble the future. We'll also then from there talk about the remarkable weather events of 2013 to 16. There was just a really wild ride over those years in terms of weather globally. And so we'll talk a bit about that, talk about the dynamics and variability behind that, and then talk about some similarities between what we're seeing then and to 2025 and upcoming 2026. And from there, we'll go into some broad forecasts for 2026 and what to expect. So there's a couple of ways to approach this. For many things, we might say because the Earth is warming, the future is not really going to look like the past. And so it's not really that useful to study historical weather trends to understand the future. And I think that this is actually very relevant when, for example, we talk about extreme weather and when we talk about details of weather patterns, because those details are changing. On the other hand, when it comes to the fact that there is year-to-year volatility, in many ways, the future does look like the past. And so in this case, studying historical weather can help us understand something about what the future is going to bring. And so this particularly has to do with patterns of weather variability, keeping in mind that some of the details change as our planet continues to warm. We can still learn a lot about how that variability evolves in time by looking historically at similar analogs. So these are always going to be imperfect analogs, but they can give us some really good insights into how future weeks, months, and years are going to play out. So from there, what are we going to talk about today? We're going to talk about some remarkable events that happened from 2013 to 16. So this all started with the winter that was just very extreme over some parts of North America, 2013 and 2014. And I'll put this in context. I think some of the context is just that we had a series of pretty mild winters, and then suddenly, boom, we were hit with this pretty extreme one. From there, we continue to have this sort of growing blob of warm temperatures over the Northeast Pacific Ocean. And from there, in 2015 to 16, we had a super El Nino. And that was so significant because we had not seen a super El Nino for almost 20 years at that point. So at that point, scientists were almost like, oh, maybe these things don't happen anymore. And so it was just very significant to suddenly see this thing go boom and appear and have sort of major global impacts, as we know that super El Ninos tend to. So from here, let's go back, first of all, to that record-breaking cold winter. So this cold winter was record-breaking, not over the globe, but very specifically over the Midwest and Eastern US and the prairies and Maritimes over Canada. So this wasn't just like, oh, well, the whole globe was cold. No, it was very regionally localized. And for folks that were in this region, it was quite extreme. So, Wisconsin, for example, was 4 degrees colder than the 20th century average, right? So, it meant that for many winters previously, people had sort of gotten used to these very sort of mild conditions, mild relative to where they were. And suddenly we had what was, perceived as a real winter. And then note, once again, the rest of the globe wasn't necessarily that much colder. And in fact, that winter was something like the eighth warmest northern hemispheric winter at that time. Those 3 winter months, December, January, and February. And so, not necessarily globally cold, but definitely huge in these particular areas of North America. And this cold weather over these regions really led to some volatility in energy markets, which I think is why many folks in financial markets really remember this winter, study this winter, think about this winter, and wonder, oh, is the next one going to be like this? So, what we saw this particular winter was a huge spike in natural gas prices as well as electricity prices. And I think that those were particularly significant when you look at them against the backdrop of the fact that there was a huge slump in these prices in previous years. So we had an economic slump in 2008, right? A huge crash. There was a growth in fracking, which tended to drive down natural gas prices. We had a ton of mild winters, so energy prices stay low. And so, especially against that background, suddenly having a very significant winter over parts of the country that tend to be cold anyway was just a real shock. And so there was a lot of volatility that particular winter in terms of energy and electricity prices. So, what caused this particular cold Midwest, Eastern US, Maritimes, and Prairies, Canada event? So if we look at some of the fundamentals, many of them are not particularly remarkable. So, we had this kind of QBO that was in the process of flipping from its eastward positive to its westward negative. And so, as we know, a negative QBO is great for polar vortex events, but at this point, because it was in the process of flipping, it's hard to say that this particular configuration led to a weak vortex. We did have some fun MJO activity going on at that time. So, and we know that phases 7 and 8 tend to add to cold North American weather. So there was some of that going on. We had greater Eurasian snow cover at that time, which was interesting and would have favored sort of a disrupted vortex. So, okay, that's like another detail that maybe was helpful in generating this kind of winter. And so was neutral, so also somewhat helpful. But the NAO never really strongly flipped to a negative. And so in that case, I mean, that doesn't necessarily suggest an extreme winter. And so what we think is that, just from the literature and from sort of looking at the weather patterns, we think that probably the blob contributed quite a bit to favoring this kind of cold weather pattern. And so this blob was a marine heat wave in the Northeast Pacific. It created some ridging patterns, particularly over the Northeast Pacific Ocean. And from there, favored this kind of troughing pattern over the Midwest and Eastern US that tended to favor this cold air advection from the Arctic, this kind of somewhat stretched vortex, and having the jet, kind of wave downward and create that really, typical cold wave type of pattern. So There are many fundamentals that maybe slightly favored this, but really we think that the ocean was in charge here. And so let's look at the evolution of that blob. So here we're at 2014, and we can just see that North Pacific Ocean is very warm. The warm anomaly kind of dissipates a bit in the winter and then is growing again in the summer. And then suddenly you can see as we get into 2015, the entire North Pacific Ocean from the higher latitudes all the way to the tropics is very warm. And so this was a really remarkable event. It drove the weather and it had huge implications for ecosystems. So it was a major marine heat wave. It just decimated fisheries, led to billions of dollars in losses in fisheries and aquaculture operations up and down the coast of North America. Some of these fisheries, like various sardine fisheries in California, have not yet totally recovered. And this was 10 years ago. So, yeah, huge impacts. There were also huge impacts on marine mammals and birds. And as we said, we think that this may had a major role to play in that really cold winter over North America that particular year, because it likely altered the weather circulation over North America and sort of favored that cold Midwest and Eastern North America pattern. We also have some evidence from the literature that the blob might have favored the coming 2015 to 16 super El Nino. So let's take a look at that. So this is, okay, so we're at 2016. Let's wait for it to kind of get to the end of 2016. So as I mentioned earlier, people were really confused for a while as to why we had seen super El Niños in the 80s, in the 90s, but, we didn't see any in the 2000s. And so, there is this question when you don't see anything in the observations, what exactly is going on in terms of the likelihood of these events in the future as our climate changes? And so there were some questions at that time, are we expecting that super El Niños are less favored on this warmer world. Well, then this event came along, and it was just, in some respects, it was likely the strongest El Nino in the observational record. So the Nino 3.4 index was the highest that we have ever seen before. And this El Nino had major impacts around the globe. So it contributed to a ton of fire weather in certain regions that became very dry. So Southeast Asia, Australia. It contributed to really major humanitarian catastrophes, including droughts in East Africa. Luckily, I think that these regions got a lot of aid at that time. And so there was hopefully a lot of loss of life averted, but still really serious. It was a really intense typhoon season over the Pacific. And so, yeah, it was one for the history books because the Pacific Ocean was so warm and was just, sort of genesis of cyclone activity was just really high. And then there was also just record flooding at many locations around the world. This particular figure is from Texas, but so many regions around the world experienced record-breaking flooding that year. So it was just a year that was one for the history books. And so now, coming back to the present, right now, we are in winter. It's 2025 to 2026. There are some similarities between the winter of 2013 and 2014. So, first of all, in terms of thinking about the QBO at that time was not necessarily the thing that was kind of instigating the polar vortex events that we saw. Whereas now the QBO is sort of really in a good mode for these weak polar vortex events that we are seeing. At that time, we had kind of similar ENSO conditions. And so at that time, we had a neutral ENSO. Today, we have a very weak La Nina, near neutral. So that is kind of similar to these sort of fundamentals that we saw back in 2013 and 2014. A huge factor that I see that is like very interesting is that we do have a second blob in the Northeast Pacific. I will say that this blob looks a little bit different because the Gulf of Alaska is actually a little bit colder than usual. The blob is sort of displaced a bit westward. And so it has different meteorological effects. And so this particularly is similar, but it's also not exactly the same. And then finally, we have had, a strong MJO. And this strong MJO, both from 2013 to 14, as well as 2025 to 2026, has helped contribute to cold snaps, particularly when the MJO hangs out in phases 7 and 8, which did happen during this winter and has already happened this winter as our first cold snaps of the year have played out. And so in fall 2025, we actually did see the earliest polar vortex weakening ever. And so this was an earlier recording from an earlier webinar where, we sort of watched that polar vortex weakening and subsequent cold snap play out. And so, yeah, this is a winter that really lends itself well to these cold snaps. And this is something that we've been saying since September. It is a very cold, snappy winter that lends itself very well to a weak polar vortex. Right now, we are still in sort of the midst of this cold snap caused by this polar vortex event. And what we see in the forecast is that the polar vortex will likely remain stretched for the next few weeks. And so we can expect sort of continuing cold snap conditions over the east of North America and into Canada. So now let's look at the forecast going forward. And to begin, I just want to say something about long range forecasting. So with long range forecasting, we use Earth system models to capture memory within the Earth system beyond 14 days. This includes the ocean, which has an extremely long memory, the land surface, and the ice. And this is very different from weather modeling, where we just use an atmosphere model to understand how the weather evolves over the next few days. And one thing to remember is that with Earth system modeling, particularly when we look at these long range forecasts, we can't tell you a day-to-day forecast, say 3 months into the future, but we can tell you, for example, for that particular month, is snow favored, for example. And this can be very useful information when it comes to planning operations and figuring out what the future holds so that, yeah, the future doesn't have to come as a surprise. So let's look first at January to February 2026. And what we see here is likely continued weather volatility, winter weather volatility. And so the reason for this is because the QBO is still in its easterly phase. We have a neutral El Nino index. And we have really strong north-south temperature gradients over North America. And in addition to this, we still expect a strong MJO to continue to play a role with cross-Pacific teleconnections. So we expect some good predictability for some of that temperature volatility. So keeping track of the polar vortex will be important, as well as continuing to monitor that MJO, which we will continue to do. And just a little note, the MJO is relatively weak into early January. So I guess this is a good time to be taking a break from webinars because it's not going to be telling us very much. But the polar vortex is still stretched. It's quite active. And so that is going to continue to sort of play a role in this cold snap that is still continuing. And so Thinking about spring 2026, are we going to have an early start or a late start? So, we think from the forecast that we can expect an early spring over most of the lower 48 in the US and most of Eurasia. And so, especially sort of the Nordic countries and Russia in particular. But pretty much most of Eurasia is sort of warmer than usual at the time when spring starts. However, keep in mind that Canada and Alaska are sort of in a league of their own here. Both of them appear colder than usual. And so we might expect that these regions are going to have a slightly later start to the spring this year. And I think this is actually likely going to, that it might play a role in, for example, resuming mining activities over some of the areas in Canada and Alaska where mining is a really important industry. When it comes to late spring and early summer of 2026, what we do see is that the blob is still there. And once again, you can see in the Gulf of Alaska, there is still this sort of cold anomaly that is persistent. But this is a huge blob, and we see temperature anomalies here up to 1.5 degrees Celsius. It's this sort of over 5,000 mile long persistent sea surface temperature anomaly. As we mentioned earlier, it showed up in our forecast in September. And yeah, it has, even despite the winter where it has weakened a little bit, it still is holding on. And so we think that this is something to keep track of. And depending on how this manifests into next fall and winter as well, it could continue to be a big driver of the weather. However, probably the elephant in the room is this potential El Nino. And so, what it looks like is moving into summer 2026 and beyond, it is possible that we are going to move into a at least modest El Nino. There is a good possibility of that. So, what about a super El Nino? Well, there are a couple of factors that are going to help determine whether it's a super El Nino or a relatively modest one. And by the way, that exciting 2015 to 2016 El Nino is right here. And you can see that it is literally the largest in our record that we have been able to observe. It has the largest spike. So what would favor kind of a similar type of event in 2026? So one thing that we're going to keep track of are westerly wind bursts over the tropical Pacific in late winter and early spring. And note that we have a very strong MJO generally right now, favored by the fundamentals with the negative QBO. And so because of that, yeah, these westerly wind bursts are actually favored because the MJO can help drive these. And so we're going to keep track specifically of these particular westerly wind bursts as we sort of come into 2026 so we can sort of make our educated call about what to expect about the magnitude of this possible El Nino in 2026. We also think there is some evidence from the literature that North Pacific temperature anomalies can help instigate strong El Nino events. And so this is also something that we will continue to keep an eye on. Does that blob continue to grow? Well, that is going to make a big difference into whether this El Nino ends up being on the extremely strong side. So this is another area where we will continue to track this and continue to monitor the likelihood of how severe this El Nino might become. And so that concludes the last webinar of the year. So I want to wish everyone a really happy holidays from Planette and our team over here to you. And I want to say also that we would love to see you at our first webinar of 2026. It will be on January 7th, and we have a really great guest, David Grantham, who is founder and CEO of Redwood AI. And we will talk specifically about data center operations and using weather insights to ensure that these operations are sustainable and resilient. And if you miss us a lot over the winter, you can find us on YouTube. All past webinars are posted there. So there's a lot to watch. Yeah, feel free to check those out and keep in touch. We're on LinkedIn. We are on, you can find us on the web at our website. You can contact me at hansi@planette.ai if you have any conundrums about the weather. And I would love to tell you more about what we do and see if there might be some opportunities for collaboration and working together. So thank you so much. And I'm happy to take questions.
Thank you.
Thanks. Okay, so I'm looking at the chat right now, and I see that Dr. Femi has a question. So Dr. Femi wants to know regarding the localized forecast. I see that that is around 9:53. So my guess is maybe this is related to our Canada forecast. Um, so here's the thing, right? These weather patterns that we're talking about, these are very large scale weather patterns. And so, in particular, if we're talking about a mountain area, it will still be subject to the same weather patterns. But for example, the higher up in the mountain you are, for example, the later that spring will come. Right. So essentially, what that requires is just like a topographical downscaling. And so that is something, first of all, that is already in our forecasts at 25-kilometer resolution. And so if you need a little bit more resolution on that, that is something that can be calculated. So we can work with you on that. Um, Okay, yeah, thank you, Fernando. Thank you for the happy holidays wishes. I hope that we can meet up in the new year. And thank you, James. Happy holidays to you as well. All right, folks. We're gonna wrap this up unless there's anyone else with a question. All right. Thank you all, and we will see you on the other side in 2026. Goodbye.